Hi everybody, this is Module 2, Lesson 4. We are efficiently adding integers and other rational numbers. So your essential question is pretty basic. It's just what are the rules for adding integers? And we're going to go over if they're both positive, if they're both negative, or what about when they are different signs. So just to kind of give you a preview, we're not always going to be able to use the number line. Sometimes the numbers are going to be too big. Sometimes they're going to be fractions with different denominators. So we got to know how to do it using rules. And so that's what we're going to do right now. So before we start, we're just going to go over if they have the same sign. We're going to show it on the number line and then go over the rules for it. This workbook is a lot of pages. It goes all the way to page 31. So it's going to feel like a lot of pages, but it's going to go pretty fast. So how long is the arrow that represents 3, positive 3? Well, it's going to be 3 units. And if it's positive 3, it is going to the right, or up if we're using a vertical number line. Okay, how long is the arrow that represents 5? The arrow that represents 5 is also just 5 units. And since it's positive 5, it is to the right, or up if we're using a vertical number line. We're usually going to use a horizontal number line. Okay, so what is the sum? If you want to show it up here, there you go, plus 3, and then make another one, 5 units from there. A lot of kids are having questions on that. It's 5 units from here. Okay, so what is the sum? That means where did I end up? Where did I land? I landed right here on positive 8. If I were to represent just 8 using an arrow, how long would it be? So what if I said, okay, now make 8 an arrow on the number line? Well, that would be 8 units. Sorry, let me clean that up a little. Okay, 8 units. Did I go right or left? I went right. 8 units to the right. Okay, what is the relationship between the arrow representing the number on the number line and the absolute value of that number? Okay, what that means is if I draw an arrow that is 8 units long, that is the absolute value. So the questioning here is a little confusing, but what I want you to write is that the number of units of the arrow is equal to the absolute value. Remember, absolute value, that is a term that you do need to know, and absolute value is the distance from 0. Absolute value. So you can put that in parentheses. Distance from 0. Okay, so what do you think? If you're adding 2 positive numbers, will it always give you a greater positive number, and why? Well, the answer is yes. The reason it will give you a greater, which means like even more positive, yes, because the arrow keeps going even further right. Hopefully that kind of gives you a foreshadowing of what happens when we have 2 negative addends. Okay, even further to the right. So 3 plus 5, you already know that answer is 8, but just to show you on the number line, it's to the right and then to the right again because they're both positive. So yes, the answer, this is one of your rules. Adding 2 positive numbers will always give you a greater positive because those arrows keep going to the right. Okay, like I said, that should give you a little bit of a preview as to what will happen when we have 2 negatives. So now our problem, it's the same absolute values, but this time it's -3 plus -5. Okay, let's go ahead and use arrows to represent that on the number line. For -3, we're going to go 3 units to the left. And for -5, if we add -5, we have to go even further to the left. Okay, a little bit of clue there for you. How long is the arrow that represents -3? Well, guess what? That's actually the same answer as the last one because that also has an absolute value of 3. So it's 3 units long. However, this time it is pointing to the left, or we can say down when thinking about a vertical number line. Okay, and then how long is the arrow that represents -5? 5 units. And since it's negative, it is also pointing to the left on that horizontal number line, or down on vertical number line. So now what is the sum? Where did we end up? -8. Okay, so this is really, really similar to the last example. If we were to represent -8 using one arrow, how long would it be and in what direction would it point? Well, it would be 8 units long and it would point to the left. So do you think that adding two negative numbers will always give you a smaller negative? And I kind of want to pay attention to that smaller. That's what really tricks kids up. They think smaller is getting to be a smaller absolute value, but smaller means lower. So this is going to help to think of like temperatures. -8 is colder than -3 or -5. If you have -$8 in your bank account, that's smaller or lower than -5 and -3. So that word there, you just got to pay attention. It is getting smaller, even though a lot of kids think, oh, 8 and 5, 8 is more. But these aren't positive. These are the negatives. Okay, so going to the left on the number line is getting smaller. So yes, the answer is yes, because it is going even further left on the number line. Okay, what do both of these examples have in common? So the one from page 25 and this one here. What do they have in common? Well, they have the same signs. So you add the absolute values if they have the same sign. 8:15. Okay. You add the absolute values if they have the same sign. Okay, so the rule is add rational numbers with the same sign by adding their absolute value and keeping that sign. That's the important part here. Adding their absolute values. Remember, the absolute value is the distance from 0. So their absolute values are going to be a positive number. Adding their absolute values and keeping. I want you to underline that word keeping. That sign. So if they were both positive, you keep the positive sign. And if they were both negative, you keep the negative sign. Okay, here's where you're going to get to practice. On page 27, pause the video. I want you to try exercise A. Okay, exercise 2, part A. Go ahead and try these. All you're doing is telling me, is the answer going to be positive or is it going to be negative? When you are done, you can unpause it and see how you did. Okay, for time's sake, I'm just going to abbreviate them. Negative, positive, negative, negative, positive. Even though there's 3, all 3 of them are positive. And then this one is negative. Okay, how'd you do? How many did you get right? Hopefully 6. If not, you can look at them and see that they all have the same sign. Now you actually are going to find the sum. No calculators here. Pause it. Go ahead and see if you can find the sum. Use that orange number line if you need to. Okay, so for 15 plus 7, you go 15 to the right, 7 more to the right. For -4 plus -16, you're going 4 to the left and then another 16 to the left from there. Okay, pause it and then unpause it and see if you got your answers correct. Okay, we got 22, -20, -82, and -328. Hopefully you did well on that. And if you have questions, make sure that you bring those to me in the next class when we go over these. You can ask any of those questions that you want to. Okay, go ahead and turn to page 28. Now we're going to talk about what happens when there are different signs, So for 5 plus -3, we're going to start with going 5 to the right because that's a positive. But then we have -3, so then we go back 3. 3 to the left from there. So 1, 2, 3. By the way, it's okay to put your pencil on the number line and go 1, 2, 3, and carefully count to make sure that you ended up in the right place. I'd rather you do that and then just erase it to make it clean. Okay, so we know that the arrow that represented the 5 was 5 units to the right, and that the -3 was 3 units to the left. Okay, which arrow was longer, the 5 units or the 3 units? Well, the 5 units, of course. What is the sum? The sum here is 2. If you were to represent the sum using an arrow, how long would the arrow be and in which direction would it point? Well, it would be 2 units to the right of 0. 2 units to the right. Okay, so a quick thing here is the 5 units is longer than the 3 units by 2. Okay, if you're thinking that's actually kind of like a subtraction problem. 5 and 3, well, the 5 arrow is 2 units longer than the 3 arrow. So that's just kind of a preview as to where that came from. Okay, let's try it here. Now we have 4 plus -7. 4 plus -7. So +4 goes like this. And then -7, we've got to go from there. We have to go back 7. We have to go to the left 7. Again, if you need to do this, go ahead and do it. 1, 2, 3, 4, 5, 6, 7. So I know that that's where I'm going to end. Now I can make my arrow nice and neat and have it end right there. And the answer is -3. Okay, so in the 2 examples above, what is the relationship between the length of the arrow representing the sum and the length of the arrows representing the 2 addends? Okay, so what is the relationship between the direction of the arrow representing the sum and the direction of the arrows representing the 2 addends? I know that these questions can get a little confusing, but we're going to try to explain it using those absolute values. So for the first one, what is the relationship between the length of the arrow representing the sum and the lengths of the arrows representing the addends? The addends are your 2 numbers, your 4 and -7. So 4 and -7. Okay, so the sum is equal to the difference of the 2 absolute values. You have to know what difference means, though, and I gave you a hint earlier. It is subtraction. The sum is equal to the difference of the absolute values and I keep the sign of the greater absolute value. All that means is which arrow is longer. In this case, the 5 was longer, so I'm going to put a little star next to that one. The 5 was longer, so that's why my answer was +2. Down below, the 7 was longer, so that's why my answer is -3. Okay, and then you don't have to draw this one because we'll just kind of use that there. I know the questions can get a little wordy, so I just want to make sure that we know how to do this. Okay, so write a rule. Here's going to be the rule, and this is going to count for both boxes. You don't have to do both parts of it. So we're going to write this here. I'm actually going to type it so it's nice and neat for you. If the signs are different, subtract the absolute values. And that's, remember, that's the length of the arrows or the distance from 0 on the number line. Subtract the absolute values and keep the sign of the integer that has a greater absolute value. Okay, and that will count for your rule as well. Okay, let's move on to exercise 3. I'm going to pause it and you're going to actually try those all by yourself. Take out your orange ruler if you need to. Please, please, please take out your orange number lines and you can actually show this on your number lines. Pause it. This should take you about, at least 5, maybe even 10 minutes. Take your time, see how you do. When you unpause it, I'm going to put the answers up. Pause it. If you didn't pause it now. This is the part where you learn, did you actually figure out how to do these? Okay, if you're watching, you better have written down all 8 of these answers. Let's see how you did. 1, -4, -3, -10, -3. Oh, I'm so sorry. This one says determine if it's positive or negative without actually calculating the sum. So this one is positive, negative, negative, negative. But again, there's the answers. I actually did go ahead and solve them. I guess it's because I love math so much. Okay, and then keep going down here. You did solve those ones, and hopefully you got those ones correct. Now, if any of those you didn't understand or you're thinking like, well, I got this answer and I don't know how I got it, circle it and we will go over it in class. Okay, so that was exercise 3. If you can now, go ahead and turn to page 30. Page 30. We are going to do this one in class. Okay, so for example 3, I want you to write in class. This one is a little tricky because you can see that we have a fraction. And when we get to the other fraction, we're going to do that one in class too. Okay, pause it and try exercise 4 on your own. No calculators. I know you can type this in a calculator, and that's great, but I really want you to try these 2 on your own. Okay, if you're still listening, hopefully you have answers written down here. For the sum of -18 plus 7, I hope that you got -11, -11. And for the temperature outside, it was 73, but it fell 19. A lot of kids just write it like this, and that's fine. That's correct. 73 minus 19 would give you the right answer, but we have been talking about addition, so I want you to see that these are the same. These are the same problems. Okay, and then when you solve that, you're going to actually subtract them because they're different signs. And what is the difference? It is 54. So now it is 54 degrees outside. Okay, hopefully you did well on exercise 4. And then again, like I said, for part C, we're going to do that in class, and then you can do the summary on your own. Okay, that is a wrap. I know that was a long video, but you have extra time for this video. It's not due in just one day. So hopefully you spread it apart or you set aside enough time because this is 18 minutes and I wanted you to pause it and solve them. Make sure you bring your questions to class. And don't forget that the C, we're going to be doing this in class with the fractions. And then the summary, you do that by answering the essential question. Okay, see you in class.